Our next speaker is a research landscape planner from the National Agroforestry Center in Nebraska. Please welcome Gary Bentrup.
Well, I'd like to thank Scott for that great keynote speech. It really set the foundation for this symposium. Really like to thank Gregory and Shabu at the Center for Agroforestry here at University of Missouri for hosting this symposium on a very timely subject. So I'm going to move into kind of now the agroforestry aspect of this symposium, and Scott already kind of set a foundation for that. And let's see. While I was preparing this talk, I was reminiscing about the family farm I grew up on in western Kansas. And my grandfather, Charles Bentrup, started farming this farm prior to the Dust Bowl, just a few years before, and then the Dust Bowl hit. Needless to say, producing any crop in western Kansas at this time period was a challenge. The one crop, though, that did work for him was producing alfalfa for alfalfa seed. And of course, alfalfa requires pollinators, the honeybee, and these were feral bees in the area because there wasn't really managed colonies as Scott talked about at this time. And the honeybees really saved the farm. But I also was struck by this confluence of pollinators and agroforestry as well, because this was the time period that the Prairie States Forestry Project was initiated. And what this project was by the U.S. Forest Service, and it was to deal with the Dust Bowl. And it resulted in the planting of over 18,000 miles of shelter belts across the Great Plains to deal with erosion issues during that time period. So the landscape has changed, unfortunately, dramatic from that time period. As we look here now at what crops are pollinated within our kind of region, there's not that much. So it really crop pollination makes a lot of sense in other parts of the region. Not to diminish that here, because in Missouri, we do have some crops that require pollinators. Acreage-wise, if you're a grower of these crops, it's important. You'll notice I have one up here, soybeans. What? They're self-pollinating, but there's some recent evidence suggesting that actually there can be a yield bump with pollinators, and particularly with native bees. But are we going to sell providing pollinator habitat based on crop pollination in the region? Probably not as strong. Scott made a very good case for the biodiversity aspect. Within the temperate region, 75% of flowering plants require animal pollination. But where I think this is where agroforestry comes into play. This is a way, and again, Scott alluded to this, is that we can provide multiple benefits at the same time we're putting agroforestry practices out on the landscape. And this kind of diagram just illustrates conceptually kind of the different types of ecosystem services we can acquire with, say, windbreaks, riparian forest buffers across the landscape. So I'd like to go back to that national strategy that Scott mentioned. And yes, 7 million acres over the next 5 years. And the U.S. Agroforestry Center was lucky in the fact that we were able to get agroforestry actually mentioned into the national strategy. That wasn't actually no small achievement, but as not a silver bullet, but as just one tool in helping pollinators. But now we've got the question, is agroforestry ready for pollinator prime time? What do we know in order to provide pollinator habitat with agroforestry practices? And what do we still need to know? And most importantly, do we have actionable knowledge? Do we have knowledge that we can affect landscape change in a positive direction? And so hopefully we'll kind of explore that with this talk. So the National Agroforestry Center right now is in progress on a systematic review of pollinators and agroforestry. Within the literature, if you look at pollinators in agriculture, you find a plethora of research. When you subset it out as agroforestry, it shrinks significantly. But yet, we can cross over and gather information from this broad arena of research as we kind of develop a more knowledge base to move forward. So we're going to report on some of the kind of preliminary findings of this systematic review. As we earlier talked, there's the primary pollinator groups. We also included the bats and hummingbirds in this, although as mentioned, the real emphasis in research has also been focused on bees. So this is going to be fairly bee-centric, hopefully not in-centric. So with agroforestry practices, hopefully we're at least familiar with the 5 basic groups, as well as kind of the 6th category, which is kind of a catch-all. So I'm not going to really focus on the specifics of these different agroforestry practices, but talk about what are kind of design considerations that are applicable for all agroforestry practices. And also from the perspective of existing agroforestry practices that are already out on the landscape, how we might look at them to increase pollinator habitat, as well as when we're putting in new agroforestry practices, how we might tweak them to do better service for pollinators. So, agroforestry design considerations. So I'm going to kind of just break it out into 3 kind of categories. And these are going to kind of address some of the major threats that Scott talked about. And we've got foraging habitat, nesting habitat, and landscape scale considerations. Regarding foraging habitat considerations, we've got flower diversity, we got range of bloom times, larval resources, primarily for the butterflies and the host plants, and the native plants. We've already kind of been introduced to these topics, but I want to drill in a little deeper, hopefully, and provide a little bit more information on this. So diversity of flower shapes, sizes, and colors is really important for pollinators. They have different morphology, and so they're attracted and utilize different flower resources. This kind of collage of images shows us some of the different woody plants that we have used in agroforestry practices. Elderberry, which the University of Missouri has done some great research on the potential of this plant. You can see the different shape of flower there as versus the red maple, the willows, and the blueberry. And so having that diversity will help us support that larger suite of bee biodiversity. All right, well, I always kind of struggle with putting up kind of things that start to rank plants, because then people think, oh, I can just take one plant and that's it. Our society is so ingrained on top 10 lists, and it's a little bit of a struggle. This chart, I wouldn't necessarily dwell on the numbers so much. They're just really relative rankings, and they really come from honeybee data, but it's at least a starting point for native bees. And we can kind of start to see what plants maybe have a little bit more potential for providing both nectar and pollen resources. So plants such as the willow family or the rubus, which is a lot of your raspberry, blackberry, berry families, are pretty good resources. What this chart also kind of shows is maybe what are some of the plants that might be less suitable. These still could have an important role, and we'll kind of explore that a little later. Focus in, Scott talked that the willow is a pretty important species. It's early flowering. It gets resources out on the landscape for these bees when they're emerging from hibernation. This plant has a very high level of sugar per acre relative to other floral resources. It also has high levels of protein. Pussy willow has about 22%. The more interesting fact on this is that it has a high quality protein, and research has shown that bumblebees particularly do well with this high quality protein, yielding healthier, bigger, stronger bumblebees. Kind of protein shakes for bumblebees. So now we're kind of talking about that range of bloom time. And this again is kind of a list of some of the woody species within our region. that might be in an agroforestry planting. This shows their bloom times, starting in March. The colors represent their kind of flower color, so we can kind of see what diversity we kind of have. So one of the real reasons that agroforestry practices could be of benefit to pollinators is that they could provide that early flower pollen and nectar resource for pollinators when a lot of herbaceous plants have not yet started to flower. So that's really one of the key benefits. But this chart also then kind of reveals they're not really providing a lot of resources in the late season, at least in our region. And so we can't just have a woody focus. We need to really think about agroforestry practices that can also incorporate at least a herbaceous component to provide that full range of habitat needs in terms of floral and nectar resources. So that's an important consideration. I want to also take it back out that with agroforestry plantings, we're going to be putting these in for a variety of services. And so some of the plants that were on that other chart also have the potential, in addition to providing ecosystem services such as, say, stream bank stabilization in riparian buffer situations, or a windbreak for soil erosion protection, they offer the potential for harvesting products from, and could serve as another economic diversification source for landowners. And here's just some kind of examples. Some can be harvested for some high quality wood, others for fruit. Many of these, no surprise, have real potential, or already are commercial products, botanical, also biomass for energy. So we have this potential to look at these from a broader perspective. Just going to briefly mention, Scott spent a little bit of time talking about butterflies and the importance of host plants. There's a lot more we could probably talk about on this. I just throw up again another chart just to illustrate kind of what type of plant groups have some particular values from the woody sector for butterfly and moth larvae. And we can kind of see oaks and cherry and willow are kind of some of the ones that have a little bit higher numbers of species supported. Again, don't want to negate the importance of the herbaceous element because some are specialists and just require those. And so, but just throwing that out there. All right, we mentioned the preference for native plants. It's no surprise, these species evolved with native plants, and so they're going to generally have a preference for them. And there's some great research out of California that has documented that there is definitely this preference for native plants, and particularly supporting richness and diversity. And Lauren's going to offer, I think, a bit more information on some of this great work that's coming out of California. But I'm just going to plug in a little teaser for the next talk, I think. And this one just kind of struck me kind of interesting, is that hedgerows benefited floral resource specialists more than generalists. I think sometimes when we do interventions in agricultural lands, they are perceived as just mostly helping generalists. Great, more raccoons, what we need, okay. But we can maybe provide some habitat for those more specialists. So I think that's pretty exciting. All right, nesting considerations. As we heard earlier, there is about 30% of native bees are wood nesters, and so agroforestry, again, has the potential to provide habitat for these. And species that particularly have soft, pithy centers that either carpenter bees can excavate out tunnels, or wood beetle larvae can excavate tunnels out that then the bees can use, are your elderberry, your boxwood, rubus species, dogwood, and sumac. And so these, again, are kind of species that can be easily incorporated into, say, an alley cropping system or a riparian buffer strip. Management of these can be using pruning to kind of expose the ends so that the interior of the pithy stem. And then too often, I think in agricultural settings, we have this, I know I came from a farm, it's like everything has to be cleaned up, nice and proper. You know, if there was a dead tree in a shelter belt, Dad was like, go out and take it out. But we know now we really need to kind of leave these in there. And it's not just for invertebrates, but they are a whole keystone for other species. Okay, then by and far the large bulk of our bees are ground nesting bees, and they need that undisturbed landscape. And within an agricultural setting that is often tilled, undisturbed landscape is a pretty important commodity. And the woody component of an agroforestry practice often provides this undisturbed habitat. And studies have shown that bumblebee nest densities have been twice as high in these kind of linear edge of these woody habitats, more than pure grassland or pure woodland. So if what we need to kind of consider is moving away from something that maybe looks like this bottom left, which has no real interface, to something that has a woody grass forb interface where nesting, particularly for bumblebees, can occur. Well, now let's expand out into landscape scale considerations. And kind of four kind of categories is foraging distance, spatial extent of that habitat, pesticide protection, and then multifunctionality. So there's been some meta-analysis over looking at how far do bees travel from habitat out into a crop field. And so this is just some kind of synthesis of that research. And we can see that it starts to really drop off out about 1,000 meters. And really, that's kind of a turning point there, but even at a shorter distance. So this really kind of says we need kind of habitat on a more frequent spatial scale, which again, rather than needing one big habitat patch, something that integrates multiple patches across the landscape, let's say again like an alley crop type system, could be advantageous. But foraging size or foraging distance size does matter. No surprise, bumblebees can travel quite a bit farther than your smaller bees. The emphasis is not so much on the differences, but if we're thinking about trying to conserve that range of bee biodiversity, we want to have maybe things again on a closer spatial scale so that we're protecting some of those smaller guys or providing them some of the resources as well. So take-home message here is maybe we're really looking more at 100, 200 kind of meter spacing or 300, 600 feet. What about spatial extent and area? And this type of research has been looking at, again, flower visitation frequency, how much is out in the landscape within a certain amount of area, like a 1 kilometer area. And again, some research that came out of California, I think particularly Almond Grove area, but looking at how much habitat with visitation. It suggests that at that 30% area, that's where you start to really pick up some habitat. And it's not necessarily 30% in one spot, again, collectively over the area. But that does tell us that we need practices out on the landscape, whether even agroforestry or not, that provide that level of patchiness in the agricultural landscape to provide that kind of critical threshold. Most studies, though, really haven't looked at what yield bump do you get with providing habitat. Most have just looked at flower visitation rate. This is a study that looked at sweet cherry out of Germany, and again, kind of shows a similar result in actually looking at fruit set. It really started to increase once you got at least out to 30 or more %. But so we have to look at practices that are going to provide that multifunctional aspect, because just providing or converting half of your area to, say, pollinator habitat might help your fruit set, but it's probably going to have trade-offs on the overall yield. All right. Scott kind of really brought up the importance of pesticides, and we could probably have a whole symposium just on that. And so the one kind of take-home message here is we need to provide spray drift buffers away from our places that we're providing pollinator habitat. We need to have these set back far enough that, in this case, spray coming from either aerial application or ground applications doesn't drift into the pollinator habitat. We can provide pollinator habitat we could provide spray drift protection with agroforestry practices, but if we're doing that, we really need to try to make them non-pollinator habitat so that we don't create a sink. And that brings up to this neonicotinoid. And this is now, don't have a map, but we can see how much this one has been increased over the last several years. And this neonicotinoid, when it's on the seed, when it's planted, it results in often a dust plume, a fugitive dust plume that drifts. And it's a very toxic dust plume. And so there's this window that is kind of hazardous to species during this particular time, and actually longer time because of the persistence issue. But there's been now research looking at this, and it's showing that there's been a high concentration of neonicotinoids on the woody plants, flowers that are surrounding these fields at this time. And so again, showing this study site in Ohio, your Salix, your Willow species, your maple species, your rose family, they're all collecting this drift. And then in this case, honeybees have been collecting it and getting a much higher dose than expected. So this is kind of the Debbie Downer on agroforestry. We really might be contributing some pesticide sinks, and we're going to have to explore this more. And so we have a project at University of Nebraska right now where we're looking at trying to create a drift buffer and then protect that with the pollinator habitat and work out some of the plant considerations and design considerations on this idea. So now bring it back to that multifunctionality. And again, we could have a talk all on that today. But the important thing is, whenever we try to maximize for one function, whether agriculture production, whether it's for even water quality, we would not get agricultural production if we just maximize for water quality, is that we're always having to look at how do we optimize and deal with the trade-offs. And the main thing is to think about that, and we have research and evidence out there to start to design these. And I'm not going to focus on this one, but this slide next. And this is just showing, again, a distance from say, a windbreak or habitat, and what kind of effect do you get the ecosystem service out from that distance. So we can start to think about these in terms of multifunctions. So we got increased crop yield, where you get a bump for the microclimate effect that say a windbreak would provide. We got reduced wind erosion, out so many tree heights out from that. We've already seen the pollination service diagram, and then we got conservation biological control, that more integrated pest management where we're using habitat to provide beneficial insects to prey on your insects. So what this says is, and granted these are cereal crops, so it's not true for pollinators. But I'm using these two pictures to say where we're moving from is to a more kind of integrated landscape that has these habitat features and these features that we're trying these multiple ecosystem services from at a closer scale. I'd be remiss if I didn't at least mention what are possible downsides to providing pollinator habitat. There's concern that you could maybe pull pollinators away from the crop that needs pollination. Current research suggests this is not the case. A simple management technique would be to time the plantings, your agroforestry plantings, not to have major blooming during the crop period. So that one's a relatively easy one to manage. We also have the issue, and this one is a constant one of any, that it's a source of pests and weeds. And yet research continually kind of shows that generally this is not the case, especially with management. But the devil is in the details. We need to be careful. I throw up the soybean aphid and the buckthorn as an example. Here's two introduced species. The aphid requires the buckthorn as a host plant in part of its life cycle. And the buckthorn was initially a plant that was used in some windbreaks, a non-native plant. And so we need to, again, pay attention to the details on plants. All right, just going to throw out some future research and what are some possibilities. This by far is not a conclusive list, but one area I think we kind of need to think about is habitat requirements for sustaining populations, but for two functions, for the biodiversity aspect and for crop pollination. They're similar, but they have different kind of requirements. And so I think we kind of need to tease those out a little bit more. A huge one I just alluded to is pesticides and agroforestry practices. Are we creating some sinks? You know, and also too with the main systemics, with water runoff, do these plants take it up and actually acquiring the pollen over time? And with the persistence of some of these lasting a while, this could be a real concern. And then the last one is actually looking at conservation biological control. I think conservation biological control is such a part of pollinator habitat, and there's been some great research here. I think Dr. Leonard, I think he may have already left some of the work that they've done here at University of Missouri on that. Just wrapping it up with some resources that are available. Again, on the pesticides, here's one from Xerces and NRCS. It's a great resource. Pollinator.org also has some other resources. We've got Xerces, which already plugged, but I want to plug this particular one because, again, this publication looks at biological pest control solutions, another aspect that I think really fits well in with agroforestry. And the National Agroforestry Center will have a booth out there with a lot of these publications, but we have a lot of different tech notes specifically on using agroforestry and pollinators out there. And with that, I think there's some real potential for agroforestry. It's not a silver bullet. There is no silver bullets in this. We have some concerns that I think need to be addressed, but I think we can play a role in providing pollinator habitat as well as a variety of other ecosystem services. Thank you.
Thank you, Gary. We just have just a few minutes for questions. We're a little tight on the schedule, but if there are any questions or comments for Gary, we have just a few minutes. Any?
Could you address the potential for organic farming? Nobody's mentioned the certified organic farming as a you wouldn't have the pesticide problem, and your slide with the sink, that was pretty dramatic.
Right.
So if you could just talk about that a little bit.
It's definitely, obviously, a farming system that would minimize a lot of these problems, and so that has obviously real potential. There's still a lot of ag that hasn't transitioned to that, and so we're just trying to, as that one slide said, mitigate, not necessarily solve. I mean, we like to move. It's a cohesive piece of the puzzle. So.
Any other questions?
Yeah, right here. One thing that you didn't mention was, in non-organic agroforestry systems, like, an apple orchard with, hay underneath or something. Are there any pesticides, particularly for agroforestry crops, that have been as much of a concern? Because we've heard a lot about the neonicotinoids recently, but those are sort of more from like cereal grains, from what I understand.
At least a lot of, like, again, let's take an alley cropping or windbreaks kind of systems. They've not traditionally been sprayed. It's the crop in between. So as far as any pesticides particularly used on the agroforestry planting, that's not necessarily been a problem, but it's what's being sprayed adjacent and going onto the woody component of agroforestry. I think that's where we're really running an issue, or not just drift, but uptake, runoff, riparian buffer strips, collecting it over time. Those are all, I think, some real concerns, and we don't probably have a really good handle on some of that.
Okay, I think we have time for one more question. The gentleman here.
Yes, the Missouri Farm Bureau is very politically active. Although we're members, we disagree with a lot of their policies and interest in the politics in Missouri. Have you spoken to them, and do you have any information about how they've reacted to some of these ideas?
No. I'm at Lincoln, Nebraska, so I have not had an opportunity to talk to Missouri's Farm Bureau, and have not had a chance to talk to Nebraska's Farm Bureau. They don't necessarily let me out of the office to go talk to those groups too much. So I don't have as much experience with that than, say, somebody like Scott, who has worked with a lot of those groups more closely.
Thank you.
I think we have time for one more question if there's any. Okay. Thank you.
I'm interested to know how these neonicotinoids travel in the environment and where they end up lodging and staying around.
Right.
If we talk about planting roadsides and hedgerows, is that contaminating all that?
It's, and maybe Scott might want to weigh in on this one a little more. It's one that we're going to have to explore more. Like I said, this problem is being tackled on a variety of ways. Of course, trying to deal with maybe not applying them in the first place would be obviously a step in the right direction. But even with, say, the one where the seed drift, they're working on better formulations to keep that drift from occurring. But it is a question, and this, because you saw that immediate ramp up, we're just finding out where do we even kind of need to start looking in the environment where these are being accumulated in the aquatic systems. Where are they going? Their persistence, and I wish I had better answers on that, but I don't. I don't know if you want to.
I mean, quickly, yeah, this is a concern on. This is a concern on roadsides. Wherever we're planting, we need to look at a landscape context, and they do move via soil and water. They move via drift, and they are being found outside of where they were intended to be. So we can ameliorate these problems, though. We just have to work at it, and we have to be thoughtful. There's the Johnny wildflower seed approach to pollinator conservation, which is plant everywhere. We need to be a little more thoughtful about that, because we could be, as Gary said, creating sinks in certain places where it's actually worse to plant than not. We can talk to farmers, we can ameliorate these issues, but it's a conscious effort that we have to address these neonics and other systemics.
Okay, well, thank you very much. Thank you for your questions, and thanks to Gary Bentrup for his presentation.